Yeah, so it was either going to be between AT&T or the other one.
Well, I thought that you go back.
Oh, do both?
Yeah.
Okay, yeah, they'll be tending to do both
Okay.
for that meeting.
All right.
Go ahead.
Yeah.
All right. My name is Nick Travis. I don't think I know many of you, but I've been around. I know a few faces. I've been around as an adjunct instructor for quite a while now. I wanted to talk to you guys tonight some about wireless infrastructure in a enterprise environment, and specifically the Cisco approach. This may sound like a marketing speech, and it somewhat is, but that's where I work. That's what I know. So it's really pervasive, and so it's good for you guys to know. Yeah. I stole all of these slides from the marketing department, so made it a whole lot easier on me. All right, so about me, I've worked at Cisco for about 2.5 years in service provider video, which basically means my customers are Comcast, Time Warner, Charter, cable box, your set-top box, back-end systems that all those register with. I've worked on optimization and monitoring of those systems. Actually, just in the last week and a half, I've accepted a new job in Cisco as a system engineer in SLED. SLED is State Local Government Education, where I will be out with customers, explaining the technology, helping get it set up, saying this is the problem you have, how do you solve that, what's the solution to your problem. Actually, what I'm most excited about here, I think, is Chattahoochee Tech will be one of my customers starting a week from Monday. So. Well, yeah, but before going to Cisco, I was at IBM for 10 years, worked on networking team and managing data centers. And as I mentioned, I've been an adjunct since 2005. It feels like it sometimes. Any questions? At any point, feel free to stop me if something I say makes no sense at all. Just feel free to interrupt. We can talk about it. The density trends for wireless, going back to 2000, we had a few laptops for a large number of people that were on wireless. It was really the only people that had wireless were the network technicians.
People still scared of Y2K. Not all the computers blew up on them.
Exactly. So there was very little wireless throughout a corporate environment. Go to 2010, there was basically one device for every person for the most part. Fast forward to now, and there's 3 or more devices per person. In a lot of surveys, it's not abnormal. There was recently a survey done in a high school, and the average was like 3.6 devices for every student in the school. They all had a laptop and a tablet and a phone, and they also, some of them had iPods that were wireless, etc. So there's been an explosive growth in the number of wireless devices. Also, a lot of industries have actually totally transformed the way that they work now because of wireless technology. Healthcare is crazy. If you look in a hospital now, you see everything is wireless. There's sensors on everything. Those wireless, the wireless access points can then track carts throughout the hospital and know where the food cart is, and know where the medication cart is, and know where all of the IV machines are. Those can all be tracked through the wireless access points. So it's really transformed the industry there. Education, everybody has a laptop now or your phone, makes things a lot easier. Retail is one that gets a lot of people annoyed because it doesn't provide a whole lot of benefit for the customer in the store, but it provides a huge benefit for the store because they can track everything you do. They can see, came in this entrance of our 2 entrances, you walk to this section, you walk to this section, and you left. They don't know who you are, but they know that is a person, right? They can track your phone, the wireless signals, and see where you went. And a lot of that data actually gets fed back into the stores, and they say, okay, well, we see that 70% of the people that walk into Walmart are going to the dog food aisle. So then, when they redesign their store, they move that to the back corner. So they force everybody to walk further through the store. And they may put an area that nobody ever goes to right in between where 2 people go often, force people to walk down that aisle. So, to the customer, that can be kind of annoying because you're being manipulated. But to the business, it's a huge increase in revenue. And again, looking at the trends here, in 2000, there was only a few applications that were actually relying on the network. 2010, we have a lot more. We introduced YouTube and Facebook, and there's a lot of things going on. Now, with the pervasiveness of apps, for everything, the number of applications on a network is exploded. When it was like this in the 2000s, it was easy to manage a network because you could just say, oh, we have 10 types of traffic on our network. Today, when you have all these different apps available at everybody's fingertips, the types of traffic are very hard to keep control of, to shape on your network, to make sure that your core applications can still function. You don't want somebody's Angry Birds traffic messing up your Oracle database traffic on your network, right? So there's a lot of technology that has to go into corporate networks now to make sure everybody can use all these services, but they play nicely with each other. The early days of wireless, a lot of people thought that it really wouldn't catch on a whole lot because the speeds weren't there. And this is just kind of a comparison of the wired networking speeds versus the wireless networking speeds. And if you look at it, they're comparable. The wired's a little bit ahead as far as in the years, but 802.11ac, which is our most recent standard that's out, you can go buy equipment for, it can reach up to just shy of 7 gigabit. Now, the routing of the Micro Center probably can't do that, but the standard itself can do up those much. It's like 6.9 something gigabit. And we have 10 gig Ethernet now. There's actually, you can get 40 gig, but 10 is really the more common one. So we're only talking 3 gigabits different between today's wireless and wired networks. And when you really look at an individual device, it's one of those things you should never say. Who really needs 7 gigabits to their cell phone? We're going to use it eventually. Give us a few more years and we'll be able to use that bandwidth. But today, the wireless bandwidth really is not an issue. The problem we have goes back, a few slides ago to the capacity. We have not nearly enough wireless frequencies to have this many devices all crammed in one location, especially with a residential style router. All right, one more marketing slide, and then we're going to talk about some of the specifics. So, again, going back, we had initially, kind of in the 2000s, you have a single access point, right? And this is what everybody pretty much has at home today. So you have a Linksys or a Cisco, or a D-Link, some kind of standard access point. That access point is totally managed by itself, right? If you have 2 of them and you want to make a change to your SSID, you have to log into both devices and change your SSID. There's no communication between them. There's no intelligence between them. So, fine in the beginning, but if you were to think about a campus like this, if every access point was managed individually, it would be a nightmare to make any kind of change. So then we go into what's known as the unified wireless approach. So here we actually add what's known as the controller. If you've ever heard of the data plane and the control plane and switching and routing, the data plane is where we're actually going to move the packets around. Right? It's where our data is actually being transmitted and received. The control plane is where we set up, where we configure our routes. That's where all of our ACLs are, the intelligence, if you will, of the switch is in the control plane. So with unified wireless, oddly enough, we've now split it into 2 devices. We have the controller. So the controller is where everything is configured. So you go into your controller and you say, I want a wireless network with this SSID, with this type of encryption and this password. I want it broadcast, you can give it hours of the day. I only want it broadcast between 8 a.m. and 8 p.m. And nobody needs to be on our wireless network at 2 a.m. You set all this information up in the controller. And then what you do is you take an access point, which I brought a whole bunch of, like this. This is actually one of the most recent 3702 access points. This is an AC access point. You plug this into the network. It's power over Ethernet, so you only need a single cable. You plug it up, and it broadcasts out on the network much like a DHCP signal would. It actually is a DHCP packet with a special option. this controller sees it and says, oh, hey, we have an access point. And the controller will then send this access point its IP address. Once it has an IP address, it calls back to the controller and says, okay, what do I do? These are what we call autonomous access points. It has no information on it, it knows nothing. It gets all its information from the controller. So if it needs a firmware update, it used to be that you had to plug into the console cable and you had to TFTP your code over to the device and update it. Now, it can see, you can tell the controller, this is the version of firmware I want to run. When this connects in, the controller says, hey, your firmware is outdated, and it pushes the new one down to it. It reboots, takes 3 or 4 minutes, and you've now updated the firmware on the device. One of the things that I think is really interesting about that process is it does not stay on the device. So every time the device reboots, it re-downloads the firmware, which seems kind of backwards. Like, well, why not do a hard upgrade and just leave it there? The cool thing is, if you have a firmware issue, so if you push a firmware and it's bad, all you have to do is go to your switch, bounce the port, because they're powered over Ethernet, so you can do a shutdown on the port. It turns off the access point, you can turn it back on, and then it's going to go and try to reload the firmware. So you never should you have to send somebody back out to the building, get up into the ceiling to where the access point is, and either pull it down to take it back to the office, or connect to it and try to fix something on it. So you kind of, every time you reboot it, it's like doing a factory restore. For one access point, this isn't very useful, but what happens somewhere, here, somebody sitting at any campus in their office can then go into the controller and configure how we want all the access points to be for this particular building. As they get plugged in, they automatically boot up. It doesn't matter which access point is where within the building. Generally, people will try to separate them by building, right? So they say, we're going to have 15 access points in this building. One needs to go here, 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 and here. And then they send somebody out to go install them. But if they switch 2 access points and put them in the wrong place, it doesn't matter because they're all running the same configuration.
And Nick, the access points, the connectivity from the access point to the controller is all wireless as well?
Can be. So there's some generally, they will use wired connectivity because they're getting the power from it as well.
Exactly.
Now, it is possible to do it over wireless and use a power supply. So if you have somewhere where you don't have, a cable, or it's hard to get a cable to, you can do a mesh network, basically. One of the other cool things that I've been playing with a couple weeks ago, I needed a Ethernet port in my garage because I'm an IT guy. Yeah, exactly. And I said, man, I do not want to have to run a cable out to my garage. That's the old school way of doing it. So I logged into my controller, and I took 2 other access points and set them up in a bridge mode. So the access points were communicating over wireless to each other, and then I took the Ethernet port on the access point I put in the garage, ran that out to a 5-port switch, and now I had 4 ports left in my garage. So I can bridge, and same thing you can do from building to building, from a house to a garage, an external garage kind of thing. Pretty cool feature. I did actually do 2 buildings that were about 250 yards apart, with tons of trees in between. I was able to bridge and do, they have what's known as beam forming. You can actually take the antennas on this particular one has external antenna. That's what all these little connectors are. And these are 2 MIMO, multi-output. But you can put different style antennas. You can put a directional antenna, you can put omnidirectional antennas, outdoor antennas. There are all kinds of different antennas that you can attach to these access points. And what's great about that for a corporation is they can order all of the exact same access point and then just order some different antennas. And if one goes bad, it's not, well, that's the outdoor model. We have to order another one of those. We don't have an extra one. It's just the antennas that are the only part that's different. And the antennas are much cheaper than these guys are. Questions? Does it make any sense, or following some? Okay. Yes?
So are you saying that's pretty much maintenance free? Once you put it in the ceiling, then
That's the idea.
it just stays there?
Put it in the ceiling, you don't take it down until 10 years later when you recycle it. And that actually kind of brings me to another point. These access points, one of the big concerns that people have is, hey, these things are expensive. And the standards are changing all the time, right? So if I buy this, and this is an AC access point, what happens in 3 or 4 years when our next standard comes out? Do I have to pull all my access points down and replace them? And the answer is, used to be yes, but now, future-proofing is one of the big buzzwords going around right now. So what Cisco has done is introduce these modules, and what these are, this actual antenna is this access point is, well, no, this is an AC, but one of the other ones I have over here is just an in access point, and this is a AC module, and so these will actually snap right onto the back like this, and then you've now upgraded it to an AC access point or whatever the next version is. And so I think AT is the next standard. And so all you have to do is order, however many access points you need to upgrade. You order this little module, go to all your access points, snap it on the back, and you upgrade it. And then it goes right back to the controller and gets all this big info and everything. So pretty handy little thing, and this takes it from, you can upgrade each access point for $100 a piece versus spending $500 or $600 on a new access point. So this is kind of where we're at right now with what's out in the wild. Where things are going is actually to a converged access method. The idea here I'm going to skip ahead for a second. I can talk about one more thing before we go to the converged. So we put this up in the ceiling, and all of our, here are our APs. Everybody connects to it. Now we have to put that traffic on our wired network, right? The traditional way, if we go back to when we had a standalone autonomous AP, right there was a switch, and it was just put on the network and switched. Well, in a corporate environment, you generally want to control some of the traffic. You want to make sure that people aren't abusing your wireless network. And there's no way to do that in this diagram. These are all access points, and these are our access layer switches. So these are the switches in the closet. So instead of letting these guys do the switching for any traffic that comes in here, we want to control it. So all the traffic actually is tunneled to our wireless LAN controller. These LAN controllers are just little, well, depending on how many access points you have, they're little big boxes. And actually the latest one runs a virtual machine. So this, where we can configure everything, all of our traffic is actually sent to it, where we can filter it, we can set the priority for certain types of traffic. We can force people to log on through like an 802.1x authentication. And then we control everything here. So now we actually, at this point, would put it onto the network and it would be switched as regular traffic. This gives a lot of control. The problem comes in when you have somebody like Home Depot. And Home Depot has access points in the store. And they allow customers to connect to them to browse the website or do whatever they need to do. Well, Home Depot doesn't want to put a controller in every store for their 5 or 6 access points they have, so these controllers sit back at their corporate office. Well, that means all the traffic of all the people in Home Depot, price comparing, is going back to corporate headquarters to then be put onto the network and get sent out to the internet. So it's a lot of extra capacity needed on the local store links. So what we've done now, and I say we, I mean what's been done, I didn't do any of it. We've gone to this converged access. So same idea here, we have a controller and an access point, but when we look at our diagram, we've actually taken this controller and pushed it down to the switches. So the latest generation switches, the 3850 and the, I don't remember the other one. Basically they're standard switches really, will run a wireless LAN controller on the switch itself. So you take one of your switches like these guys, not that one. is this your switch, right, the one that's mounted in the closet, but it has a virtual machine running for the wireless LAN controller in it. The technology that has gone into these guys in the last few years is kind of mind-blowing, to be honest, at least in my opinion. So we started off with single access points. We then went to controller-based access points, and we now have still controller-based access points, but our controller becomes all of the switches we have out in the closet. And then we have a single controller that will control all of these, right? So you still have one interface you can go and push things out, but this allows us to actually switch all of our traffic the first time the access point hits the network. Where that's great for somebody like Home Depot, and what a lot of these stores do is they don't have a very expensive internet connection as far as quality back to their corporate office, but it's very slow generally. Now they can come in and get a business Comcast connection, and right here in the store, they can take all their guest wireless and just dump it right on the business Comcast connection, let it go out to the internet, and then send all of their actual corporate data over their expensive, high-quality internet connection back to the corporate office. So it gives the customers a better experience, it's cheaper for the store, and it's actually more secure because as soon as it hits the network, it's totally isolated and never sees the corporate network. All right, let's see if there's anything. We basically covered all of that. Any questions?
I got a question.
Yes.
I mean, it's probably a pretty good question. We have a wireless access point, a wrap like that at the office, but ours is not in the ceiling. What's the purpose of being in the ceiling? So to broadcast the signal?
It's all about the antenna placement in them. They are made to be mounted on, well, that's right, I shouldn't say that. A standard access point, this is probably the one that you've seen everywhere because they are everywhere. It actually broadcasts out like this. So when it's up on the ceiling, it's giving you this cone kind of coverage. If you have it sitting on the desk, that cone's just going up to the ceiling, so you have better coverage on the ceiling than you do on the ground. Because of the physics behind the way the wireless works, you still get connectivity, but you will get better signal down. I actually, in my house, I have a two-story house in the basement. So in the basement, I have one actually sitting on my table pointed up, and then I have one up in the attic pointed down. I get better coverage from the one in the attic pointed down than I do from the one in the basement where I'm sitting. My desk is in the basement pointed up, because of the way the antennas are
It also makes it clear of a structure.
Yes.
The ceiling as well. You don't have a table or desk or.
Yeah, you don't get any refraction or
Yeah.
impedance or and just this access point actually has one of the modules installed on it, the AC modules in the back. So. One thing I didn't mention, with the single access points, if you had a problem, you had to go to each access point and address it. With the controller-based method, these access points become extremely intelligent. What they do, when you have two access points, I can actually take these, mount one here and mount one right here, and I could actually point them right at each other from it. And then the controller, it has this feature known as clean air. What it will do is it will see all the other access points around it, and it will find a clear frequency to use. It will say, you know what, there's a whole lot of traffic, a whole lot of noise on this frequency, or this channel, I gotta change to another one. The other thing they can do is, got the name of the feature, but it's, I forget, it's got some marketing name, but it's basically variable power. So it can say, look, we've got two access points right next to each other. They do not both need to be broadcasting at 100% because they're just going to interfere. So what they do is they slowly back off. They'll start broadcasting at 100%, see how many access points they see. They're maintained by the same controller. And then each one will slowly back down on its power until you get the 15 to 20% overlap that you're supposed to have in a nice wireless network. So it really cleans up the signal a lot. And if you're doing autonomous access points, there's no way to do that. I mean, you'd have to do it manually. It'd be a nightmare. One of the other really cool features, and I've played with this a lot, and it's amazing that it actually works, but you have this thing, this concept of rogue APU. So this is when somebody else turns on a wireless network. If somebody, could walk in here and plug in a $20 wireless router, right, and be broadcasting an unencrypted wireless network. In a corporate environment, that can be a huge security issue. So you can actually tell your controller, if we have any rogue access points pop up, kick them off the network. And what it will do, it actually sends malformed packets. And it's funny, if you do it, there's a whole legal warning that this is probably illegal where you live. Make sure you check the laws and all that stuff. But it will take an access point and just totally kick it off the network. And basically, your regular access points, because these all have 2 to 4 radios in them, it will take one of their radios and dedicate it towards knocking these guys off the network totally, so they can't connect it. I didn't think it would work, and so I tested it. It works. It's pretty cool. I was sitting there, I had a ping running on the laptop with another access point set up, and as soon as I hit contain, just the button, boom, it's gone, totally offline. So. All right. Any questions on any of that? That's real high level stuff, but you kind of get the idea. And one of the questions I've gotten many times is, why do I need to pay hundreds of dollars for an access point when I can go buy one for, I can get a nice one for $60 at Micro Center, right? And they're really just totally different technologies. They do the same thing, but they accomplish it in very different ways.
I have just kind of an odd question.
Okay.
Who did that first, hardware or software? Because what you just said seems very much to me like you've turned your access points into EJVs, just these things you pass information to do stuff, and your controller is your software. Who did it first, y'all or software engineers?
I'm going to go with the software engineers at Cisco.
Oh,
That's who did it first.
Okay.
I have no idea. But yeah, really the point is for the access points to become commoditized. We don't need these to be really intelligent devices. Let's make them cheaper and put more of them out so we can get better coverage. And yeah, bring the intelligence back. That really goes along with the whole idea behind SDN. We're going to take the intelligence out of our switches, push it into a control plane in the cloud or on a central location, and then it makes it a lot cheaper to put, basically dumb switches everywhere. All right. So that's what I was supposed to talk about. I am a guy that likes hardware, if you can't tell, and like to get my hands on hardware, so I brought a whole bunch of hardware. What I really just wanted to kind of do is show you guys, let you look at it, talk about some of the interesting things on them. Does anybody know who the #1 server manufacturer is in the U.S. or North America? IBM?
IBM.
Dell? Anybody else? HP?
HP.
Keep guessing.
Cisco.
Cisco. UCS.
Sorry.
#1 server manufacturer in the U.S. or in North America. This is recent, so it's cool. I won't hate you guys for not knowing. If you go back 5 years, nobody had ever heard of UCS. And right now, if I asked most of you in here what's UCS, maybe 1 or 2 people would have been able to give me an answer, maybe. But what's awesome about the UCS servers is the cost. Generally, you can get them for much cheaper than any of the competitors, and the capacity on them is much greater. This particular server is really the kind of the budget server, if you will. It maxes out. This model's a couple years old. Actually, it's a year and a half old. It maxes out at 512 gigs of RAM, and as you can see, only 4 hard drives. 2 processors with a max of 6 cores for each processor on this model. One of the things that I love about these, and actually all the UCS servers have it, and it's really hard to kind of show because all it is this Ethernet port right here. What this is this is built in, and every UCS server has it, this built-in lights out management. Meaning, I plug a cable into here, with this server powered off, I can go into BIOS, I can turn the server on, I have a full KVM, everything built into my server. All the manufacturers have it, but it's all an add-on. When I was at IBM, Our internal cost to add we had to add a PCI card to do this in every server was like $700 something internal cost. On the UCS servers, everyone has it built in, and it's full. You upgrade the firmware. Much like the access points, you don't need to be there to do anything at all. So you plug it in, you connect over the network. It does require Java. That's the only downside. Full-fledged Java. It's not the fastest in the world, but you load your operating system, everything. I had to install a server a couple weeks ago. I was working from home that day. Had one of the guys in the office plug it in for me, and all he had to do was plug in 2 cables: the SIMC or CIMC port and a power cord, and I was able to load ESX from home and do everything else on it. So very cool feature. So yeah, this is the C210, or no, I'm sorry, the C22, which is kind of the entry level server, if you will. But it's still, it's a workhorse. The other one that's over here is a little bit bigger. This is the C240, and this is really, it's the mid-range server, if you will. 24 hard drives. This particular model can do up to 768 gigs of RAM, again in 2 processors. These are all built to be very modular, which I will say pretty much all servers do that today, but if you need to replace a fan, they just, 2 little clips, they pop right out, and you can pop a new one in. You can do all that while it's running. Any of the fans or power supplies can be replaced while it's running. Hard drives be replaced, memory, CPU, obviously you have to turn off for that. I've got this one opened up though, so you can kind of take a peek and see what it looks like on the inside.
Nick, what operating system primarily runs on?
Everything is supported. What we see most is ESX, VMware ESX. Because, I would say 80% of the servers that I see get installed end up hosting virtual machines. Even if it's just one virtual machine, they tend to all be virtualized at this point. And it's actually been interesting, in the service provider video, it's always been appliances. Everything's been appliance-based for decades now, and everything is starting to be switched to virtual machines. And they're deploying virtual appliances because there's so many benefits when it comes to management and maintenance on the virtual appliances versus physical. So yeah, generally, VMware's ESX or ESXi, but it can be anything.
So colorful looking, what, Google? Does it say Google?
Yes, this other one here is actually a Google server. We have a surplus program at work where you can get surplus gear, so that's where all this stuff came from. This is one that I saw on there and it caught my eye because it's a Google search appliance. And I thought it was kind of cool. It is an older one, but this is when a company says, I want to use Google search in my company, right? I put the faceplate back on upside down, sorry. When a company says, I want to use Google search, they go to Google, they buy one of these things. This particular one was actually custom built by Google. They were doing their own hardware for a while with kind of off-the-shelf components. So this is one of those that they built. It's dated now, but I think it looks really cool, so I'm onto it. And when I say dated, it's got like quad core, 3 gigahertz, and it maxes out at like, I think it was 64 gigs of RAM, which means that's fine, but when you talk about servers, that's dated.
It only has 1 power supply on it.
Single power supply, yep.
So,
So again, I'm gonna leave all this stuff up here so you guys can come look at it.
How many hard drives I have?
This one is 6 hard drives.
6?
Yep. They're behind this little security bezel.
Oh, I see.
Actually, it might be 5. Yeah, 5.
Are they hot swappable?
They are. Yeah, they just slide right out. You can put a new one in and slide it right back in. Any questions about servers, or should we move on? And are we running out of time?
It's 5:58.
It's almost 6.
All right.
you can keep going. I'll stay. I already worked.
Some of us
all
are a
right.
little bit busy.
Real quick then, I'll just kind of tell you all this stuff. Cameras, Cisco is a big provider of cameras, security cameras. This is actually an outdoor security camera, a pan, tilt, zoom camera. And then we have more of a traditional style bullet camera as well. This particular one doesn't have a lens on it, that would be mounted inside somewhere as a security camera. These are all IP based, obviously, power over Ethernet as well. Switches, probably should talk more about switches since
I have a
that's what most of
question.
you guys use. Yeah.
About the cameras and whatnot.
Yeah.
There's a lot of, not a lot, but there's a growing number of systems out there that are completely wireless, run by an app. So you pull up, a wireless camera. You buy 15 wireless cameras and some wireless sensors.
Yep.
And you hook them all to an app. Are you guys having any problems with that as maybe not competition on the commercial level, but on the residential level?
No, because that's not Cisco's market.
Okay.
The security on those is pretty horrid.
Yep.
There's websites where you can go and cameras that have exploits, you can go to a map and click on cameras in people's houses because they didn't patch and all that kind of stuff. So in an enterprise environment, no, it hasn't been an issue.
Okay.
Two other quick things I wanted to mention on some of the later switch technology, actually three things. The latest switches running the latest version of IOX actually run Linux. It boots Linux on the switch, and then Linux loads iOS through virtualization. There's a switch running over here under the server. Power is a big deal now. Everybody wants to reduce the power, and switches historically have pulled a lot of power all the time, just sitting there doing nothing. This switch over here has what's known as energy-wise. The idea is it will only use the power it actually needs. So it's over there running right now, and it sounds about like a laptop. When I first plugged it in, when I got here, heard it boot up, it sounds like a jet engine. And that's when it's running at full power. It boots up at full power, and it says, oh, you know what, I'm not doing a whole lot, and it scales back down. And it runs at basically the same power as a laptop, which is great for places like this where half the day at least, you have switches sitting mostly idle, so you can save all that power. The other thing is modularity. The switches have all gotten to where, wrong release. Power supply, right? So this particular switch takes has the ability to hold two power supplies, and they're hot swappable. So if you have a power supply die, your monitoring goes off because you have a power supply die, you walk over to it, hit this little button, slide it out, pop your new it in. And again, going back a few years, if you had a power supply die and a switch, this would have been, they were built in. Also fans. Fans was one of the other things that died a lot in switches. The bearings would go bad. So the nicer switches now have gone to this removable fan. So if you have the bearings go bad in the fan, $50 you can buy a new little fan. Certainly it's overpriced for a fan, but it's a lot cheaper than a switch. And you can just pop it in again with it up and running. No issues. I have a whole lot more to say, but I have no time, so. Any questions?
Is all this stuff yours, or?
It is.
You borrow it, or?
It's mine through work, so.
There.
Yeah, I use some of the stuff at home, most of it not.
Storage more in this, or stuff?
Yeah, it's for demos and to show people and to showcase the technology. All right, well that said, if anybody has any questions, let me know. If you want to look at any of this stuff, feel free to look at the server over there.
Did my class all sign in? Who has to sign in?
Look at this one.
Yeah, so we get funding to make it look better.
He's got it in.
Sorry, taking some of your class time.
Funny.